Hello students, today with the help of this video, let us learn about trends in the modern periodic table. The different trends that is given in the modern periodic table and in your syllabus are as follows. First, valency. Second, atomic size. Third, metallic and non-metallic properties. Fourth, electropositivity. Fifth, electronegativity. Sixth, ionization energy. So these are the different trends given in the syllabus, in the present syllabus. So let us learn one by one. First, valency. Valency is the combining capacity of an atom. It is determined by the number of valence electron present in the outermost shell. If you observe the given picture here, sodium has 3 shells. The number of electron present in the outermost shell is 1. So it gives out this 1 electron to attain the stable octet configuration, nearest noble gas configuration. By giving this electron, it gains a positive charge. Similarly, chlorine has 7 electrons in the outermost shell. These 7 electrons are the valence electrons. But chlorine accepts this 1 electron to gain or to attain the stable octet configuration. Therefore, the valency of chlorine is 1 minus. Since it takes 1 electron, gains 1 electron, it gets a 1 negative charge, and sodium donates 1 electron, it gains a positive charge. And therefore, there will be electrostatic force of attraction between this positive and negative ions that is formed, and it helps in the combination or combining of atom. Therefore, valency is the combining capacity of atom. Sodium had 3 shells. Outermost shell had 1 electron. You can observe here it donates this 1 electron, gives 1 electron and gains a stable octet configuration. Similarly, chlorine already has 7 electrons, 7 valence electron, but it takes 1 electron to attain the stable configuration. Therefore, it results in a molecule. This is all about the valency. The next trend is atomic size or atomic radii. Atomic size refers to the radius of an atom. It is the distance between the center of the atom or nucleus to the outermost shell of an isolated atom. So this is the atom of lithium atom. So the distance between the center or nucleus to the outermost shell is referred as atomic radii or atomic size. This is the nucleus, chlorine atom. This is the nucleus, center of atom, and this is the outermost shell. First shell, second shell and third shell. So the distance between the center to the outermost shell is the atomic size or atomic radii. Let us understand the trend that we observe in the periodic table. What happens to the atomic radii as we move across? As we see the elements arranged across the periodic table, here the atomic radius or atomic size tends to decrease. Why is it so? It is because of increase in nuclear charge, nuclear force. Similarly, as we move down the group, the atomic size increases due to addition of new shells. Here is a chart. You can observe here the first period, second period. Observe this second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So here, what do you observe in the size? As you go across the period here, across the period we observe that there is decrease in the size of the atom or radius of an atom. It is because of increase in nuclear charge. Similarly, observe this first group. hydrogen, lithium, sodium, potassium, rubidium, cesium. As you see this group, you can notice that there is increase in the atomic radii or atomic size. Why is it so? Because we have observed that in first, that is hydrogen, there is only one shell. In lithium, there are two shells. In sodium, there are three shells. As we move down the group, there is increase in the number of shells. Since there is increase in number of shells, the distance also increases. The distance between the nucleus and the outermost shell also increases due to addition of new shells. This is the reason why the atomic size increases as we go down the group. Here is a simple activity. Atomic radii of the elements of second period are given here. Observe, but it is not arranged in order. You need to arrange it. So observe this. Take this table. Write down the elements symbol and the atomic radius given here. And try to solve the simple questions. Arrange them in decreasing order of their atomic radii. Write down this atomic radii and try to arrange them in decreasing order. After arranging, find out, are the elements now arranged in the pattern of a period in the periodic table? Try to find out whether it is correctly arranged as it is given in the periodic table. Then find out which element have the largest and the smallest atom. Finally, try to write how does the atomic radius change as you go from left to right in the period. So these are the simple questions based on the second concept, that is atomic size or atomic radius. Try to solve the simple questions. Dear students, till now we have learnt about atomic radius or atomic size. And we have seen that the atomic size decreases as moving from left to right along the period. This is due to an increase in nuclear charge, which tends to pull the electron closer to the nucleus and reduces the size of the atom. Atomic radius or atomic size increases down the group. Just now you have seen the example of hydrogen, lithium and sodium. There is increase in the atomic size down the group. It is because of addition of new shells. The next trend that we are going to learn is about metallic and non-metallic property. We have observed that to the left side of the periodic table there are mostly metals like lithium, sodium, magnesium, iron, rubidium, calcium. All these are metals. So mostly metals are placed on the left side of the periodic table. And here to the right side, chlorine, carbon, boron, phosphorus, sulfur, bromine, all these are the non-metals that are placed to the right side of the periodic table. So, by seeing this, by observing this periodic table, what can we interpret? Yes, we can see that metallic property is seen more in the elements present to the left side of the periodic table. And non-metallic property is seen more towards the right side of the periodic table. So, metallic property decreases as we move from left to right. As we move from left to right of the periodic table, the metallic property goes on decreasing. Similarly, non-metallic property increases as we move from left to right. Metallic property increases down the group. Non-metallic property decreases down the group. The next trend that we are going to learn here is about electropositivity and electronegativity. So first of all, let us understand what is meant by electropositivity. Observe this given image. Very similar example here I have taken about sodium and chlorine. So here you have observed that sodium donates one electron and chlorine accepts one electron. Here one electron is given by sodium and chlorine takes one electron. Observe this image. Yes. So the tendency to lose electron in this particular image, you can observe which atom is losing the electron. Yes, it is sodium that is losing the electron. So after losing the electron, what is the charge it is gaining? It is gaining a positive charge. It is getting +1 positive charge. And chlorine is gaining one electron, and since it is gaining one electron is extra here, it is getting a -1, that is negative charge. So the tendency to lose electron is called electropositivity. Metals are electropositive in nature. So in this example, sodium is a metal and it is electropositive in nature since it donates the electron. Chlorine is a non-metal. It gains the electron. It accepts the electron. Therefore, chlorine is electronegative in nature. Electropositivity, electronegativity. Electropositivity is the tendency to lose electron and electronegativity is the tendency to gain the electron. So non-metals are electronegative in nature and metals are electropositive in nature. This is what we have learned from this given. Now let us understand the trend of this electronegative nature. What happens to the trend of electronegativity as we move across the period and down the group? Across the period you can observe the electronegativity increases. As we go across the period, non-metallic nature increases. Therefore, the electronegativity increases across the period and electronegativity decreases down the group. The next concept that we are going to understand, trend that we are going to understand is ionization energy. What is ionization energy? Just now we have seen metal loses electron, non-metals accept electron. Whether to lose the electron or accept the electron, it needs some energy. So, the energy required to remove the outermost electron or to add one electron is called as ionization energy. Whenever it loses the electron, it becomes electropositive. It becomes positive ion. Whenever the atom gains the electron, it becomes electronegative. Electronegative in nature, it gets a negative charge, it becomes anion. Negative anion. So, to become a cation or to become an anion, it requires some energy. So, this energy is nothing but ionization energy. Ionization energy required is more across the period. Just now we have seen across the period nuclear force is more. Since nuclear force is more, we need more energy to remove the electron. So ionization energy required is more across the period because of increase in nuclear charge. Similarly, ionization energy required is less down the group. As we go down the group in the periodic table, the ionization energy required will be less because there is increase in number of shells. There is the distance between the nucleus and the outermost shell is more. So nucleus has less force to the outermost shell. Therefore, ionization energy will be less as we go down the group. We can observe here as we move down the group, since there is addition of new shells, ionization energy will be less. But ionization energy required will be more as we move across the period because of nuclear attraction. Thank you.